writing the formulas of ionic compounds. Ionic compounds are made up of ions. That does not mean that the compound overall has a charge. In fact, just the opposite is true. All compounds are electrically neutral. In the world, almost the only example we have where we commonly see non-neutral stuff is a thunderstorm. Part of the cloud is positively charged, and part of the cloud, or the earth, is negatively charged. Lightning is what happens when that separation of charge gets too large and tries to rebalance the charge. Compounds, ionic or otherwise, do not do this. So if ionic compounds are made of ions, how can they be electrically neutral? If the number of positive charges and the number of negative charges are the same, then the compound will be electrically neutral. In other words, if we add the positive charges to the negative charges, we must get 0. Let's look at a few examples. Sodium ion is Na+, and the chloride ion is Cl-. If I want a compound made of these two ions, then I need only take one of each ion. So the formula of the compound would be NaCl. In terms of charges, we have 1 plus 1 minus equals 0. If we want a compound between magnesium and sulfide, then again, we need only take one of each ion. So the formula of the compound is MgS. In terms of charges, we have 2 plus 2 minus equals 0. If we want a compound between the sodium ion and the sulfide ion, then we need 2 sodium ions for each sulfide ion. So the formula is Na2S. Again, in terms of charges, this would be 2 times 1 plus, which is 2 plus 2 minus equals 0. If we want to make a compound between aluminum and sulfide, things are at first glance a bit more involved. Clearly, one of each ion will not work, nor will 2 sulfides and 1 aluminum. How do we find the correct ratio of ions? One way is to find the lowest common multiple, or LCM, of the 2 charges. LCM is the smallest number that both charges will divide evenly into. The multipliers are then what we need to get the charges to that magnitude. In this case, the lowest common multiple for 3 and 2 is 6. So the multiplier for Al3 plus is 2. And the multiplier for S2 minus is 3. So the formula is Al2S3. Suppose we want to make a compound between K plus, potassium ion, and the polyatomic ion, sulfate, SO4, 2 minus. The 2 minus charge on the anion applies to the whole ion, not to any part of the ion. So we would need 2 positive charges and 2 K plus ions to balance the negative charge of the SO4, 2 minus. Therefore, the formula of the compound would be K2SO4. What happens if we need more than one of the polyatomic ions? For example, suppose we want to make a compound between magnesium ion, Mg2+, and chlorate, ClO3-. We need two negative charges to balance the two positive charges from the Mg2+, so we need two of the ClO3- ions. However, if we write the formula like this, MgClO3-2, we might get the impression that we have 32 oxygen atoms and one chlorine atom, which is not what we had in mind. To clear up this potential problem, we place the polyatomic ion in parentheses and place a subscript telling how many we have after the closing parenthesis. Like this, Mg parenthesis, ClO3, close parenthesis, 2. Some notes on writing the formulas of ionic compounds. Number 1, the number of ions of each type we have in the compound are written as subscripts, smaller numbers below the line of the symbols of the elements, after the element or ion to which they refer. So we immediately see from the formula how many atoms there are of each element. Number 2, when we write the formula of an ionic compound, we are careful to not write the charges of the ions. The only thing written is the formula of the compound, which has no charge, because it is electrically neutral. Number 3, we always place the polyatomic ion in parentheses if we need more than one. It is not necessary for monatomic ions, or if only one polyatomic ion is needed. However, be careful with the polyatomic ions that do not have any subscripts, like OH- or Cn-, for example. It is easy to forget to write the parentheses when we do not have the subscripts to